This is Unit 2, Video 8. In this video, we'll talk about how to name a very important class of compounds called acids. Now, we'll actually spend a whole chapter learning about acids on their own, about their properties and reactions. But here we're just learning how to name them. There are two types of acids. Most are either binary acids or something called oxyacids. And binary, the prefix bi, as you'll see, will be two, made of two elements. Oxyacids, as you'll see, will contain oxygen in them. The two most famous acids probably are hydrochloric acid, which is HCl, and sulfuric acid, which is H2SO4. One of these is binary. This is HCl. One of them is oxy. This is H2SO4. Sulfuric acid demands the respect of all chemists. Very dangerous and very important acid industrially. And hydrochloric is what most students deal with in the laboratory. This is the acid that you get to play with when you take chemistry. Alright, so binary acid is made of hydrogen and a nonmetal. So the example here is hydrogen and chlorine. To name it, you put the hydro in front, then you make the nonmetal, name the ending of the nonmetal ic, put ic at the end of it, and then add the word acid. So in the case of HCl, you have hydro, you have chlorine becomes chloric, and then you put the word acid. So you have hydrochloric acid. And that's why we name HCl hydrochloric acid. The oxyacids contain hydrogen and then they contain a polyatomic ion, and that's where the oxygen comes in because it's some sort of ate, like sulfate, phosphate, carbonate. And the example again here is sulfuric acid, H2SO4. To name it, you have a polyatomic ion, so it's all about this polyatomic ion, naming the polyatomic ion. If the polyatomic ion ends in 8, here it says if you have an 8, then the ending becomes ic. If the polyatomic ion ends in ite, then you put os at the end of it. And in both these cases, you've got the polyatomic ion, then put the ic, and then put the acid. Notice there is no hydro. This is important. You do not put the hydro in front. The hydro is reserved for the binary acids. So in the case of H2SO4, this here is sulfate. So 8 becomes ic, and you call this sulfuric acid. If it were sulfite, then it would become sulfurous acid. And we'll do a few examples. In fact, here they are. The first one is HNO3. Now, here I don't have a binary acid. All I have are oxyacids. So let's actually add one more example. Let's begin with a binary acid. Let's add H. Let's do I. Just as an example. So we'll do that one last. In fact, we can put it down here. HI down here. And so the first three we'll do are the oxyacids. The oxyacids are based on the polyatomic. So we have to know the name of this polyatomic. This is very famous, nitrate. So the 8 becomes ic, and you get yourself nitric. And then you put the word acid at the end. It's really as simple as that. No hydro. You do not need to name the hydro. The hydro are reserved for the binaries. So just simply nitric acid. Here we have CrO4. This is chromate. And so chromate becomes chromic acid. Simple as that. Chromic acid. Now, what I want you to notice is that the first acid, nitric acid, has only one hydrogen. Chromic acid has two hydrogens. And the reason for this is because nitrate has a -1 charge, chromate has a -2 charge. So the number of hydrogens balance the charge on the anion. The last one here is HNO. Now this here is also a polyatomic ion, and it's related to the nitrate. This is hyponitrite. Remember, NO3 is nitrate, and then if you have one less, it's nitrite, and then if you have two less, it's hyponitrite. So this is hyponitrite. And so what we do is ite becomes os. This becomes os. So we'll call this hyponitrous acid. because I becomes Os. Alright, these are the three oxyacids. And then the binary acid needs the hydro. Notice none of these have hydro for the oxyacids, but for the binary you need a hydro. So put hydro in front. And then you got iodine, so you got iodic, hydroiodic. It's all spelled together. So let's make it a small I. Hydroiodic, and then put acid at the end. So you have hydroiodic acid. Hopefully not too bad. Go ahead and try 3 on your own. All these are oxyacids. And then we're going to mention one final idea which applies to many of these naming conventions. There are old naming rules which are used sometimes still, and they're actually, that's the old naming rules made it into the naming of the acids. So the old naming rules use the original element. So for example, instead of saying iron, they'll say ferric or ferra. They'll use the original Latin name. And then they'll use ic for the ending if you have a higher charged metal. So for example, for iron, if you have a +3 charge iron, you call it ferric. And then you use the os ending for a lower charged metal. You actually use, for the iron +2, you say ferros. Now this applies to both ionic and covalent compounds. And here are some famous examples. So again, with the iron, this right here is actually ferric chloride. Whoa, I got it backwards. I apologize. Let's try that again. This actually should be FeCl3. This is a typo. And this should be Cl2 because the higher charge gets the ic ending. Now the reason why FeCl3 is the higher charge is because you should have 3 chlorides. That's how you get a +3 here, and this should be a +2. So ferric chloride for the higher charge, and ferrous chloride for the lower charge. And here is a few examples of covalent compounds: nitric oxide and nitrous oxide. Now the reason you know that nitric oxide has a higher charge on the nitrogen is because you have 1 oxygen with it, so this must be a +2, whereas you have 2 nitrogens here, so this must be a +1. So that's how you know the first one is ic, the second one is os. Now in the case of acids, if you have, for example, sulfuric acid versus sulfurous acid, if you take a look at these, the formulas for them, sulfuric is H2SO4 and sulfurose is H2SO3. The same exact concept follows. Now, the higher charge here is actually on the sulfur. The sulfur, if you calculate the sulfur's charge, you'll see sulfur has a +6 charge on here. Now, we haven't talked about these, but this is kind of going deeper into, this is actually called an oxidation number, not a charge, but an oxidation number, which is kind of like a charge, but not a full charge, because nonmetals usually don't have full positive charges. And then in the case here, you actually have yourself a +4 charge. So if you were to take a look at the charges of acids, you'll see the same exact story, and that's why the acids retain the naming convention. All right. So why don't we practice a few? Go ahead and practice a few on your own. Try to name these using the old rules. Remember, you want to use the original name. So PB won't be lead. You'll have to use plumbum. So you call it plumbic or plumbose. Alrighty, this wraps up the unit for us.